Hello, and welcome back to Tech Dives. In this episode, we're going to be discussing one of the most important aspects of computer science, a rapidly evolving field within it, called distributed systems. Now, what are distributed systems? Many of us have heard of it, we've come across it in many different aspects, but we don't really know what exactly is the crux of distributed systems. So, a distributed system is a collection of computers that come together to perform one singular task. This could be anything from running a web server to processing financial transactions or even providing large data sets. What makes distributed systems so powerful is that they allow us to harness the power of multiple machines and essentially scale up our computing capabilities in ways that were previously unimagined. By harnessing multiple machines, we can perform tasks much more faster, more reliably, and essentially quicker, and with greater efficiency than we could with a single computer. As you can expect, the field of distributed systems or distributed computing is essentially rapidly evolving, changing up and making new waves, and there are more opportunities now more than ever with the exposure to things like Internet of Things, big data, cloud computing. There are more chances to actually make a real impact in the world of computing and essentially building large-scale applications. So if you're interested in learning more about distributed systems and how you can actually apply them in your own development processes, stick around. We have a lot to cover and I can't wait to dive in with you. So let's go. So let us understand what distributed systems actually mean in their simplest form. A distributed system is a collection of computers that come together to act as a single computer to the end user. These machines have shared states, they can operate concurrently, and any of them could fail without actually affecting the system as a whole. A prime example of such instance is the concept of a database cluster, right? A user thinks they are talking to a single computer hosting a database, but actually talking to an array of computers hosting different database instances, clusters that talk to each other in terms of a master-slave connection structure. We will dive more into that in later videos. So why distributed systems? Like these type of systems, they're not easy to maintain at all. They are just a collection of computers that are meant to connect with each other, and this is usually chock full of pitfalls, different issues. They are hard to maintain, they are hard to debug, and they are hard to scale most of the time, depending on the circumstance, right? So why even go there at all? Well, the distributed systems allow for horizontal scaling. Going back to our database example, right? The only way to actually scale a database instance on a particular device, a particular computer, right, is to do what we call vertical scaling, which is essentially upgrading the hardware of the node itself, or the computer that it's running on. At some point, we're actually going to find that even the best hardware is not enough to actually get us the amount of performance that we need in terms of handling larger and larger amount of traffic or data, right? Now, this is where horizontal scaling comes into play. This simply means adding more computers to the network, right? Adding more nodes to the cluster instead of increasing the capacity of a singular node. In fact, horizontal scaling is cheaper, right? Once a certain threshold has been reached within vertical scaling. Now, with horizontal scaling comes several benefits, right? First of all is fault tolerance. With regards to fault tolerance, a single node could fail and your service is still up because there are other nodes that can take up the capacity, so the system doesn't just crash because of one node. So there's no single point of failure essentially. And there's also the benefit of low latency. So let's assume you have several nodes in several different locations. You will always likely connect to the node that is closest to you, right? So will your users from different locations. So they always get the best service in terms of retrieving data, connecting to the node or performing operations, right? Because they're actually connecting to the node closest to them. Unlike a singular service which might be far away for some users and closer to some other users. Now, for distributed systems to actually work, you need to run software on these different machines that actually coordinates these systems together and helps handle the problems of running the concurrent operations between them. Right? This is no easy feat. There are different types of distributed systems, right? Within the different phases of technology, and we're going to explore the crux of all of these systems in later videos, right? But for now, let us actually get an overview of what these systems are. The first of them being distributed data stores. Now, more commonly known as distributed databases, these are systems for storing data in a distributed fashion, and they try to strike a balance between consistency, partition, tolerance, and availability. Now, many of them are actually NoSQL databases, right? DynamoDB, MongoDB clusters, things like that, right? So these are distributed databases. The second that comes into play is distributed computing systems, right? This is where big data comes into play, right? Google is a big player in this space, and they're actually responsible for a lot of advancements within this particular process. Now, this actually involves breaking down large computational tasks into smaller tasks that are being performed on multiple nodes and putting the answers together, right? So one of the techniques in this space is pioneered by Google is the map reduce technique. And that technique that comes to mind is the lambda architecture and the kappa architecture. Now, up next is distributed file systems. Now, this, as the name implies, these are systems for keeping multiple files in a distributed pattern or a distributed manner, right? Saving them in multiple locations or data stores. This is different from distributed database, obviously. Now, distributed file systems, two main file systems come into mind. There's the HDFS, the Hadoop distributed file system, and there's the IPFS, the interplanetary file system. This is actually a P2P file system, a P2P distributed file system. I'm very familiar within the blockchain space. It's mostly used for NFTs and other data sets like that. Next that comes to mind is the distributed messaging system. So essentially, these messaging systems allow you to actually decentralize your messages and events, right, and store them separate from your application logic, and enable your applications to be able to talk asynchronously with other applications within their ecosystem, decoupling the logic from each other, right? An example of tools within this particular space are tools like RabbitMQ, tools like Kafka, tools like Amazon SQS, that is the simple queue service, and tools like Apache ActiveMQ. These are all distributed messaging systems, and essentially the bulk of these actually make up the core architecture of most distributed systems as of today. Now, one could argue about setting up load balance services and then setting up different nodes actually collect information from an endpoint. Let's give an example. Let's say for several Node.js servers, 5 instances, right, that are sitting behind a load balancer and receiving requests from the load balancer and sharing states with one database. Yeah, that could seem like a distributed system, but they are not exactly coming together, right, to seem as one application. They are different applications performing different operations in their own nodes, right, and they're not still on different computers. This is usually within one computer. Or let's say you create several instances, like it's several Dockerized instances, right? They're all sitting on the same computer, so this is not exactly distributed architecture, right? So you could use distributed architecture tools within their development, like the distributed messaging service, maybe RabbitMQ or any of the other MQ services, Kafka or the rest. Or you could also intentionally make them distributed services by actually serving them on multiple nodes, right? Amazon really helps with this, right? So the definition of distributed systems sometimes can seem very fuzzy, but it's more about distributed computing, right? Spreading the computing power between multiple nodes, multiple computers. So yeah, that brings me to the conclusion of this particular video. In this video, we discussed about distributed systems in general, the idea of horizontal scaling, its benefits, how it impacts our processes of building applications, and the different tools and systems that actually come into play. In our next video, we will be diving deeper into the different distributed systems, right, and actually take a closer look at their specific features and challenges. We would also cover some real-world examples of how these systems are actually being used in several different industries, right, and how they actually apply in real-world scenarios. So please stay tuned, and I will see you next week. Please do well to subscribe to the channel if you want more content like this, and comment, give me some ideas and feedback on how we could improve this. And yeah, see you next week. Peace.